Okay, so now we'll discuss about center of mass, which is otherwise called as center of gravity. Okay, so it is something like this. So let us say this is my origin. So this is my coordinate system. So we study about center of mass. So this is my x-axis and this is my y-axis, right? So let me say I have different masses. Okay, so different masses distributed like this. Okay, so the let us say this is 1, this is 2, this is 3, and this is 4. Okay, so let us say the CG of this mass 1, like the center of this mass 1 is here. So this 1 is at a distance. Sorry. So this is at a distance. This is at a distance x1 from the origin. So this point is my origin 0, 0. Okay.
Yeah.
So this is at a distance x1 from the origin, and y1 x1 and y1 from the origin. Okay. Okay.
Yeah.
So similarly, let us say this point 2. Okay. Okay. So this is at a okay. So this is x2 and this is y2.
Y2.
Okay. Similarly, let us say this is
X3.
x3,
Y3.
y3. And then similarly this is x4 and y4. So there is, you understand, there is some, the straight line it is little bit bent and all. So it is perpendicular. So
Yeah.
these are perpendicular.
Yeah.
So if the masses are distributed like this, these four masses will have a equivalent location. Okay. So it will have a equivalent location. Okay. Where the center of these four masses will be concentrated.
Okay.
That is called center of mass. Okay.
Common location.
Common location. So what actually it is, because suppose you imagine that these masses are, the weight of these masses are acting perpendicular to the plane. Okay. That means if you just consider the moment about x-axis. Okay. So what it will do, like say it will cause some like it will cause actually w, the moment will be moment about origin. Okay. So the moment about origin. Okay. So moment about origin will be like say w1 x1, w2 x2, w3 x3, and w4 x4. Okay. Okay. So this why it is w I have put, because w is a weight and it is same as force, which is nothing but m1g. So
Yeah.
force into distance is moment.
Yeah.
Okay. So this x1 distance. Okay. So x1 distance means it will cause the moment about y-axis, because this is your y-axis. This is x1 distance. It will rotate about y-axis.
Okay. Like that.
So this will, I can say that my about origin. Okay, like this I can write. Similarly, this my, this mass actually I can write it as a like, so this, otherwise I can write it as effective mass. Okay.
Okay.
Or what is the effective mass here? It is nothing but your effective weight, W1 plus W2 plus W3 plus W4 into the xCg. Means this Cg will be somewhere in the center. It will be somewhere in the center.
Okay.
Okay. So this Cg will be somewhere in the center. So this Cg will be somewhere in the center, and that Cg distance is nothing but your xCg. xCg. Okay. So that so I will write it as W1, W2, W3, W4 into xCg is equal to W1 x1 plus W2 x2 plus W3 x3 plus W for X4.
X4.
Okay. So now I know W is nothing but my everywhere that G term will come.
Yeah.
So let me cancel out that G term.
Okay.
Okay. So now it will become M1 plus M2
Be
plus
common.
M3 plus M4 and G cancels
Common.
out. That is XCG is equal to W1 M1 X1 plus M2 X2
G cancelled out.
G cancelled out. M3 X3 plus M4 X4.
X4.
Okay. So that means XCG will be equal to M1. So we write it like this: sigma M1 X1. Okay.
Mm-hmm.
Sir, I sigma Mi Xi. Okay. Mi Xi.
I from
I varies from 1
1
to 4.
to 1.
1 to 4 divided by sigma m into XCG. I can write the XCG outside. Sorry, XCG I have just sigma
XCG
m.
is there
Already XCG I have taken
in
out.
that side.
So that means XCG is equal to sigma MIXI divided by sigma m. Okay. So that is the meaning. Okay. So once you know X, similarly you can write it as
For Y also.
YCG is equal to sigma I is equal to 1 to N MINXI divided by sigma m. This is small m, sorry, small m. Okay.
Okay.
Sigma m. So this sigma small m becomes big M.
Yeah, understood.
So now you similarly ZCG also will be
The other coordinate
Ah.
axis.
I is equal to 1 to N and then MIZI divided by sigma m. So now you understand why I have put weight first, because weight is nothing but a force. So force can cause a moment.
Yeah.
So force into distance
Is the
this.
more.
Okay. So this one it has a very good implication. So suppose you have a system where you have mass m1 here. Okay. So you have mass m1 here. Okay. Mass m1 and you have mass m2 here. Okay.
Yeah.
And then let us say your CG lies here. Okay, let us say CG lies close to M1
Yeah.
and the distance is so they have given it as R2 here and this they have given as R1. Okay.
Yeah.
So what happens if you take moment about CG, so moment about CG will always be 0.
Yeah.
So CG is the point about which moment will always be 0. So that means what will happen? Let us say CG,
In this system.
in any system,
Okay.
moment about CG will be 0.
Okay.
Because moment about the CG point will be 0. That you just remember. So in this case, the moment caused by M1. So what will happen? This M1 means it will be acting as a weight, G if you multiply. And this M2, this will also be acting as a weight.
Yeah.
Okay. So this M1 is nothing but it is weight W1 and weight W2.
Yeah.
Okay. So this means W1 into R2 is equal to W2 into R1. This is a moment. This is a moment. So this minus this is equal to 0. That means this term is the moment about this axis. The moment caused by W1, moment caused by W2. So one moment will be in this direction.
Other one will be that
other one
to
will
balance
be
it.
in this direction. So this is your clockwise direction. Sorry, this is your clockwise and this is your anti-clockwise.
Anti-clockwise.
So these two moments will cancel out each other. Okay.
Yeah.
So that means if somebody from this relationship, you can find out the CG also.
Okay.
Suppose you have two masses. Okay. Two masses. Okay. You have two masses. Okay. So your if M1 is equal to M2, if M1 is equal to M2, your CG will be at the center.
Okay.
Okay. But if M1 is greater than M2, your let us say this is R1, okay, and this is R2, okay. So if your mass is high, the moment R will be less.
Okay. That means it will go towards that side.
because mass is high, moment R will be less.
Yes.
So M1 greater than M2
So
implies
R2 will be greater.
R1 is less than R2.
R2 will be greater.
Okay. So that is
That means
huh.
it will shift towards that side.
So in this equations, this relationship M1 R1 is equal to M2 R2. So from this you can find out what is R1. From one side you can
Yeah.
get it. So R1 is equal to M2 by M1, M2 by M1 into R2. That also you can write. Okay. So if you know two
That
masses,
is if they are equal.
no.
Oh, if they are not equal also that.
If they are equal, it will be at the center.
Center.
But if they are not equal,
To
this
balance
equal.
it out, R1, R2 will change.
So knowing this relationship, you can find out the location of center of
Center of
gravity.
mass, understood.
Okay. So what you see in your weighing
Weighing
balance,
scale.
in your whatever in our what is it called, balance?
Spring balance.
No, not
Weighing
spring balance.
balance.
This we are measuring the mass.
Weighing balance.
Weighing. So what
Weighing
we have-
scale. Weighing scale.
So weighing scale. So here you will have the fulcrum. Okay.
Yeah.
So one side you will have this, and another side you will have this. Okay. So because you are putting 1 kg here. Okay. So and you are putting 1 kg
Weight here.
1
Weight.
kg weight you are putting. So again this you are putting 1 kg mass.
Then it will balance.
So then only it will be balanced. So if you put in case of 1 kg, if you are putting
But because
1.5
masses are
kg,
equal.
this will go
Go
down.
down.
So this and this are causing. So this is moment balance about the fulcrum. So
Understood.
that means about the fulcrum moment is 0. So that's the. So
About the
if
center.
you have any question like this, this is one of the important formula. These are some of the important formula, and also this is another important formula. I have seen some numericals on this. Okay. Okay, so now we'll try to find out, you can take a picture. Now we'll find out the moment of the center of gravity of different standard cross sections.
Systems.
Okay, so this. Now you understood how we derived the coordinates of center
Yeah.
of gravity with respect to origin,
Yeah.
and what is moment and how we have derived all that.
Yeah.
Okay. So now center of gravity of a rectangular cross section. Okay. So the rectangular cross section, the center of gravity will be. Okay. So if my width is B, okay. If my width is B and let us say my height is A. Okay. A. Okay. So here let us say this will say L. Okay. So my CG will be at B by 2 and L by 2.
Yeah.
That will be my CG. This is my CG point. And for triangles, so this is my triangle. If this is my triangle, my CG, I draw a line joining to the bisection by the middle point of the other
Base.
side. Okay, so this is my this one, and this will automatically be this, and this is my CG.
Yeah.
So this CG, so if this height is at h, okay, my CG will be at h by 3. This will be at h by 3.
Understood.
So from the vortex h, it will be 2h by 3. Okay. And for a semicircular ring, so for a semicircular ring, okay, so this is my semicircular ring, and this is my radius. Okay, so this is my semicircular ring, and this is my radius. Just remember that this is this. Okay, so my CG will be somewhere here. Okay, and the the distance of the CG from the base will be 2r by pi. Just remember this, 2r by pi.
Radius.
2r by pi. Okay, a semicircular ring. Okay. This is a ring. Okay.
Yeah.
And there are some other things are there, like a hemispherical cell, a hemisphere, and all that. Okay, for a hemispherical cell and a hemisphere.
Okay.
Cell means it is completely empty. So if
Hollow,
it is a 3D,
hollow.
so if it is a 3D, and that will become a hemispherical scale, and this y will become r by 2. For cell it is r by 2. So
Okay.
just you have to remember those things. So now coming to a cone. So for a cone, you can refer those. These are standard things.
Okay.
So if you understand the concept, that is important. So for a cone, my CG of the cone will be. Okay, so this is my cone, and this is. So here you will be your CG. Okay. So your this distance of this CG will be h by 4. So if this is h,
H
this
by
is h
4.
by 4. Just remember, for cone it is h by 4. But so this is a solid cone. Okay.
Okay.
So
Then
just
hollow
remember
cone.
the solid cone. For hollow cone it is h by 3. Okay. So okay, so this is about center of gravity. Next we will do moment of inertia. Okay, now you understood what is center of gravity. Okay, so we have completed in the previous one circular motion, then center of gravity.
Yeah.
Okay, now next we will do moment of inertia in the next session. Okay, thank you.